We started this module by looking into the outer-facing contract, a combination of resource identifiers, HTTP methods, and, optionally, payloads. As far as resource identifiers are concerned, there is no standard for naming resources, but pluralized nouns are used most often. You should convey meaning when choosing them. Don't name an author's resource orders. On top of that, a model often has hierarchy, and that should be represented in the identifiers. Most of all, it is important to be consistent. But you can also be a bit pragmatic. Sometimes remote procedure style calls don't easily map to pluralized resource names. It is okay to divert from them for exceptional cases. HTTP methods are the second part of our contract. We had a look at the common ones which we'll encounter during the rest of the course. On a technical level, routing helps with this. Routing matches a request URI to an action on a controller. And the last part of the contract was the payload. Resource representations are sent to the API and returned from it as specific media types. The accept header tells the API what representation to return in the response body, and the content type header tells the API the format of the representation in the request body. This process of selecting the best representation of a given resource when there are multiple representations available is called content negotiation. Requests can work out as expected in different ways, and they can go wrong. That is where status codes come in. This is what the consumer of the API can inspect to know if a request worked out as expected, and in such a case, how it worked out, and if something went wrong, who's responsible for it. Level 200 status codes mean the request went well. Level 400 status codes mean the consumer made a mistake. That translates to errors. And level 500 status codes mean the mistake is the server's responsibility. And that translates to faults. Speaking of what's happening, sometimes faults do happen. In those cases, it is important to not return a stack trace, as that exposes implementation details. Moreover, consumers can't do anything with it anyway. Very important is the difference between entity model and outer-facing model. The entity model represents database rows as objects, and the outer-facing model, sometimes referred to as DTOs, represents what's sent over the wire. Separating these leads to more robust, reliable and evolvable code, and it will later on allow us to implement more advanced features. Lastly, we learn to support head. It's the same as a GET request but without a response body. It can thus be used to obtain information on a resource without having to potentially send over the response body, thus decreasing bandwidth usage. So, everything we learned in this module was held together by that outer-facing contract, as it is so important. Principles like URI design, using the correct HTTP methods, status codes, and content negotiation tie all of this together. They are all tools and principles, if you want, to implement that outer-facing contract, preferably in a RESTful way, of course. Up until now, we're just reading resources. Let's learn what to keep in mind when manipulating them in the next module.